Hi, so I was on a bit of an AliExpress shopping spree a couple of weeks ago and I came across this. This is advertised as a Wi-Fi enabled circuit breaker, and this looked pretty similar to the sort of circuit breaker you'd find in the UK. We call them consumer units or power distribution boards that typically see circuit breakers. That's a very typical example of what you see. These are both advertised as being RCBOs, which stands for residual circuit breaker with overcurrent. So they combine the function of a residual current breaker. Again, we call them RCDs in the UK. Elsewhere, they're sometimes called earth leakage or GFCI, ground fault current interrupters. They all basically do the same thing. So the idea is that they protect the downstream circuits against overcurrent, but also leakage from mains to earth. So, for example, if there's water ingress or somebody touches a live wire, the idea is that it trips and cuts the circuit. Now, I thought this could be a really bad idea. The reason this is a really terrible idea is that it looks like a normal circuit breaker, and we'll go into details as to why something that looks like a normal circuit breaker but has this additional functionality is such a truly terrible and potentially very dangerous idea. Having said that, I can see some actual genuine use cases for something like this, which I'll go into later. We've got the traditional sort of feeling on-off control circuit breaker here. We've got this flag that shows the mechanical position of the contacts. Now, this should be independent of the lever switch, because if you hold it on, it should actually be able to internally trip and show that flag without you being able to jam it in the on position. Test button for the residual current test. There's a little OLED display here. Got live and neutral in, live and neutral out here. There's a section here with a small 4 contacts, which I suspect might be for an RS485 add-on, because there is some mention of RS485. There was a plastic cover strip over this that seems to have fallen off and got lost. It wasn't attached particularly securely. And in addition to the test button, there's also a button here which controls what appears on this little OLED display. So this little OLED display can show various things. This little button here selects what it displays, although when it's switched on it's actually quite annoying to get to it. The actuator blocks it a little bit. Base settings, voltage, current, power, temperature, and I think this is actually the temperature of the terminal, so you can detect if there's a bad connection causing overheating. Earth leakage current, which could be quite useful for doing diagnostics. There's an ID. I haven't figured out any way to set this. I'd imagine the idea is that you can set different breakers in a cabinet to different IDs, but so I haven't immediately found any way to set that. Kilowatt hours, I'm not sure how you reset that, but again, sort of running total of energy. That, I've no idea what that is. That could just be a software version number or something. I haven't found any reference to that in the documentation. Okay, so this thing's got this you basically have to be on the same wireless network as the device. So you give it a password, it logs onto your local wireless network, and then you communicate. The most basic functionality is you can remotely switch it on and off. So I can just press that, turns off, and it just turns on again. Now, that alone makes it a dangerous, stupid idea, because you have something sitting in a distribution board which looks, to all intents and purposes, like a normal circuit breaker. So, for example, someone might doing maintenance come, okay, fine, we'll come along, we need to do some work on it, turn it off. It's a double pole breaker, so I've isolated live and neutral, fine, we're now safe to work on it. And then someone who's sat on the end of this circuit saying, well, why's my circuit breaker gone off? Let's see what's going on. No! Now, if you were doing it properly, you'd actually have some sort of lock-off thing, and you can actually get clips that go over these for locking them off, so that when you're working on it, you can actually lock it off to prevent anyone coming along and turning it on. So let's pretend that we've got a lock-off on here and just manually hold this and see what happens if we turn it on. It buzzes, it sort of tries to move and fails, and it's then basically jammed. I'll just check, I think that's probably off, but let's just check. Yes, that is actually switched off, and the only way that you can unjam this is to remotely do a cycle, so you can turn it on, off again. It's now back to normal operation. So, I mean, at least it doesn't like override and turn it on. But if you had like a not particularly strong lock-off device, it's conceivable this could actually override it, cause it to turn on unexpectedly. Yeah, that alone makes it fairly terrible. But there are some other interesting things that make it at least as terrible, if not even more so. You can set a timer. You can set it up either repeated or one-off events to make it switch on or off at any time. So again, you've got another situation, you might turn it off and think it's off, and then the timer said, oh, it's time to turn, and it'll just turn itself on, apparently randomly. Because we've got over and under voltage trips, and most of these functions you can tell what to do in these situations. So for example, turn off if the voltage goes below 165. And for most of these settings, you've got three options. You've either got it to tell it to trip, send a notification, or do nothing. So for example, we set an under voltage trip, and we reduce our supply voltage. After a few seconds, it trips, which is a nice function. But again, we have this potentially dangerous situation. You know, voltage is tripped out. You've got under voltage, something's gone wrong, someone's now trying to investigate the system. Voltage returns back to normal, then about 10 seconds later, it turns itself back on again. Wonderful. Now this is a function that you have to explicitly enable. If you go into advanced, there's auto reclose, so auto close enable, so you do have to have that enabled, but yeah, the fact you can do it is not great. So what other stupid and dangerous things can this do? Well, okay, the overload function. This is a normally 20 amp device. It's labelled 20 amps here. Now, it does let you set the current trip, but it won't actually let you set it. It won't actually let you set it over 20. You can actually try, but it will then, after a couple of seconds, it resets itself, and you see it's actually set itself back down to 20 safety. But what you can do, go into function control, and just go to overload, and disable it. Now it doesn't give you any overload protection at all, and there's no indication on the display or anything that this is now not a circuit breaker anymore. Okay, to test the overcurrent, I've just got this simple setup: a variac into a toroidal transformer, a couple of turns secondary, which is injecting current between the live in and out, so it's injecting current into its current sensor, just so I can easily test high currents without having ridiculously high power dummy loads. Now doing this does trip the earth leakage function. But of course we can just go into the leakage function here and just turn it off. So we now have no earth leakage detection. Even though the test button doesn't work. And we can now inject current in and see what happens. So we've currently got it set to overload trip threshold at 20 amps. So if we increase the current, it's about 5 seconds delay and it does trip. We can reduce that down, so let's say we put it on 3 amps. It's now tripped. There doesn't seem to be any time characteristics, so at 3 amps, if I just crank it like right up to a really high current, it doesn't seem to trip any faster. It'll be interesting to see if there is any physical circuit breaker at all, like maybe a thermal one in here, but it does appear to be pretty much entirely software controlled. If we just turn the overload function off, we can quite happily stick sort of 50 amps through it, and it just sits there as if nothing was happening. So this is a thing that looks like a circuit breaker. This is very much not a circuit breaker at all. Okay, let's take a quick look at earth leakage RCD functionality. I've got a 4.7k resistor there, which will generate an earth leak of about 50 milliamps. It's just connected diagonally between live in and neutral out, so I don't have any worries about tripping upstream breakers. This is all set to the default values now, so the trip's enabled and the threshold is set to 30 milliamps. So turn it on, trips out straight away. I haven't got the equipment to do a test. Well, part of the normal way of testing these in the UK, it actually measures trip times at various different currents. I haven't got a simple way of doing that, but it does trip. So let's change the leakage value. Highest it will allow is 100 milliamps, which is that is a standard for some larger breakers. For example, you're protecting certain types of installations where you might have 30 milliamp breakers downstream, so that it trips the downstream one first. Turn it on, not tripping. If we look at the display, you see that's about 49 milliamps, and it's not tripping. Yeah, that leakage current display is potentially very useful in certain scenarios. The test button still works, and so although we can set this current to whatever we want, we probably wouldn't want to set it below 30 because of capacitance and just normal leakage that you get from things like EMI filters. But of course you can just turn it off. One thing I'd need to check, if that test button is putting a resistor across the load, does like pressing and holding that, is that likely to burn out the test resistor? An LCD test resistor is normally rated, expecting the thing to trip as soon as you press it. Now if you can press that and it never trips, is that going to just burn that resistor out? Actually, I've just turned it off and I was going to measure the resistance between neutral in and live out. When I press that button, we can see we've got about 2.2k across there for that resistor, which at 240 volts will dissipate to about 26 watts. So I suspect that resistor won't last very long if you disable the RCD function and keep pressing that button. And again, in a scenario where someone's not familiar with this thing, they might find, okay, the thing's not tripping, press the button, why is it not tripping? And suddenly the thing's probably going to burst into flames. Now, although the printing's a little bit blurry, this does claim conformance with IEC 61009, which is the standard for RCD type devices. Now, I've not read IEC 61009, but the standards do tend to be quite fussy about things like labelling and marking. Now, this is actually marked as C20, which is a longish time delay, 20 amp overcurrent, and 30 milliamp residual current. So the fact that this can be remotely reconfigured to make those figures meaningless, I'd be willing to bet that actually is non-compliant with IEC 61009. Let's just take a quick run around the other functions of this app. That never gets old. There doesn't seem to be any way of assigning names to these, because obviously it'd be good to, if you had lots of these, tell it, have some text description of which circuit it controls stored in the unit. But even, there's that ID value, but even that I can't see any way of actually accessing that. We've got things like total electricity usage, real-time voltage, current and power. No real-time earth leakage, which is something which could potentially be useful in a fault-finding situation. And when I first installed this thing was generating an alert every time I turned it on and off, but it seems to have stopped doing that. I'm not quite sure why. But we do have some history information, so we have timestamps, but all it says is open close overcurrent events. It does actually show the overcurrent as an event, but it doesn't tell you the current. But also it doesn't discriminate between a manual open close versus an RCD trip. So this history information isn't hugely useful, or certainly not as useful as it could be. Settings, so we've got over voltage, under voltage, trip current, again terminal temperature value, again that could be useful to detect overheating, power limiting. So to summarise, all these are potentially useful functions, but not in a device that looks like a circuit breaker. The very fact that even this is beautifully built, superb construction quality. The very fact that a device that looks like a circuit breaker can disable those functions means it is a very dangerous, potentially dangerous product, because someone could come along to a board not knowing exactly what, expecting to find normal circuit breakers, for example, switch it off, go to work on a circuit, and then find it just switches itself back on again, which is potentially lethal. It's just absolutely crazy. Something which did everything that this claims to do, but in a different type of package, or something which is very clearly labelled that says, this is not a primary overcurrent protection device. Situation I can see that where this might be useful is, for example, where you've got a temporary setup, and you've got temporary power being provided, let's say for an event. If you've got one of these, as basically, obviously you need to have the proper upstream protection. But if you've got your local distribution box has one of these in it, that gives you a lot of very useful information for quickly debugging fault finding. You've got the voltage current, you've got all this information there, including earth leakage. So if you've got a problem, so let's say something, you're getting occasional RCD trips, and you see that the normal leakage is hovering around the 20-30 milliamps. Then that gives you information as to why that's happening. You could then perhaps make an assessment as to whether you consider that safe and increase the threshold, or change how devices are connected. So in some situations this is potentially a very useful device. Or similarly, the remote control aspect, again, in an event type situation, to be able to remotely particularly turn things off, remotely monitoring could be really useful, but not in something that looks like a primary safety device. I think we need to take a look inside this and see if there's any other horrors, or whether it's actually quite nicely made. So there's at least one more board underneath here, but on here we've got Holtec HT7017 energy monitor chip, so that's what's going to be doing all the metering. There's a power supply chip here, fairly standard switch mode controller for non-isolated supplies. There's a MAX 3085 RS485 transceiver here, so that's for that 485 port here. Got the mains coming in here. That would imply that the 485 is probably not isolated. I'd imagine if there's a clip-on 485 module here, there's probably 485 and power here to run some isolated 485 type thing. But if that's the case, why would you have a 485 transceiver here and not TTL level if the transceiver is external? It doesn't look to me like this is isolated from the main, so that seems a slightly bizarre way of doing things. We've got a geared motor here, driving this gear, and I'm sure there's you can see a few shafts here, so there'll be a train of gears going up towards the rotor that actually lets it turn the switch. And this is separated into two sections, so this is probably this is the functional switch on this side and the motor on this side. Maybe you can see if there's any actual current protection at all on that other side. And there's an RF module here, I'm guessing. So the other side, this PCB, there's an HC7126A. I can't find any data on that, but I suspect that might be connected with the power metering stuff. There's a processor over here. I suspect it's a Chinese version of one of the ST processors. It's marked ACM32F070. A chip up here, can't read the markings, but I'm guessing that's probably an E-squared prom, judging by the pinout. The transformer for the switching power supply here. MOV here for transient protection. Interesting looking at the connections on this 485. There's only two connections coming out of here, so I wonder if maybe they're doing something sneaky, like you're running at a fairly high frequency and connecting an external pulse transformer or something to it, but it doesn't really make sense as a pure RS485 interface like that, because you need some isolation and there's no power to power the main side of the isolator, and so it doesn't really make sense why you'd run 485 if you need an additional isolator after it, so a bit of a mystery that. Here we can see the gear train, which seems to work in two different ways depending on whether it's tripping or resetting. For tripping, it seems to use this lever that goes through to the other side. I wonder if that's for speed, because that does seem to operate like a mechanical trip thing. The other sides are perhaps that's just so it sort of sits on there so it can trip quickly. And you see the back of the that tiny little OLED. It's on a little subboard there. It's a cute little OLED. Looks like they're actually windowing off. They're only using a small part of it. What is a bit of a concern is that you've got the mains feed coming into the board here, and there appears to be no fusing at all. Obviously, if this is part of a distribution system, it could be connected to a supply cable of, maybe 100 amps or something. Yeah, it goes straight into this MOV with no fusing, through this diode into this capacitor. So if those failed short, then this whole thing could make quite a substantial pop and cause a fire. Here's the test resistor for the RCD test. It's 1K8, so that will dissipate a huge amount of power if you disable the RCD function and hit that button for more than a few seconds. That's just going to incinerate itself. Now the board down here looks like it's got it's like a switching regulator. Just looking what's passing through here. We've got the live and neutral. There's another two wires, and that could perhaps be one current transformer. And then we've got these two greens and two reds. So we'll pull the other side apart and see if we can figure out what those do. Okay, on this side we've got a conventional circuit breaker. We've got this coil around the trip mechanism, so that's going to provide the fast tripping on very high overload currents. There's a coil around here which passes through to the other side, so that's how the controller can trip it in the case of an RCD fault, maybe also lower overcurrent faults. There's a current transformer here which goes across both live and neutral, so that's going to be the sensing coil for the RCD functionality. That's what these two pink wires are. Two green wires will go into this trip coil. Over this side we've got these two wires that just go either side of this piece of copper, so this is clearly being used as a current shunt. And the rest of this looks like the normal sort of fairly convoluted mechanical arrangement for a conventional circuit breaker. So this is the bimetallic strip that does the thermal part of it, so as it heats up it sort of starts bending in this direction, hits this lever, which I think then pulls that to trip it thermally, so for a longer term overload. Not sure what the rating this will be. May well be this is the nominal 20 amp rating of the breaker here, because the thermal key obviously will take several seconds on a minor overload, but I'm surprised we didn't manage to trip this when sticking 50 amps through it. The overall current protection at least does look sort of fairly conventional, and this is the arc path, so when this opens the arc is guided through here to these plates where it will split up into multiple arcs, and then the large area of metal will cool it down to quench it. And then just a vent at the bottom so that any rapid expansion of gases vents out of these ports here rather than making the whole thing explode. And there's another identical contact section underneath this extra layer. I've not taken that apart because that Might be quite hard to get back together again. I'd quite like to keep this working, but as I say, it is a double pole switch. Notice there's a little magnet in this wheel here. There's some devices on here. I'm guessing one or possibly more of these are actually hall sensors that are detecting the position of that magnet, so it knows how far it's gone. So it does appear like this is built around a sort of standard circuit breaker, although I suspect it has more than a 20 amp nominal rating. So looking at the typical tripping curves, I was running 50 amps through it, and that should have tripped in under 10 seconds. And I've tested it for much longer than that, and it still wasn't tripping. That could be because I only tested that after I'd taken it apart, but just looking at how far that strip was bending, I suspect it may be perhaps a 32 amp breaker, and then they use the software electronics to get the lower rating and the adjustability. But overall the build quality looks fine. It's just the concept is just completely wrong and stupid, on a number of counts. Firstly, you've got a device that looks like a circuit breaker, which claims it's got a 30 milliamp earth leakage detection, but that can be disabled and overridden, so it may or may not have, therefore can't possibly comply to the IEC specs that it's claiming to. And secondly, the fact that this can be remotely switched on from either a timed event, remote access, or after recovering from an over or under voltage situation, which means that something in this form factor that does that is just downright dangerous. There will be people that don't realise the dangers of that and install these in place of, sort of as like an upgrade to a standard circuit breaker, and it's just really, really bad idea. And so there are definite use cases for most of the functions of these things. I wonder if maybe they could they could even just make the thing in a completely different colour of plastic to make it differentiated, and have some sort of warning to say, look, this is not something that you should use as your primary means of isolation and protection. Reasonably well made, but a completely stupid and dangerous idea.